Now this question is little bit tricky, okay, but it is very simple. A cube of iron, some data given, is heated to a very high temperature and is placed on a large block of ice at 0 degrees Celsius. The cube melts the ice below it, displaces the water and sinks. In the final equilibrium position, the upper surface just goes inside the ice. Calculate the initial temperature of the cube and neglect any losses of heat outside the ice and the cube. Alright, now one thing, that first of all, let the volume of the cube be V. Alright, so mass of cube will be density into volume, so density of iron into its volume. Fine, this is the mass. Now by the Archimedes principle, we know that if a body is placed in a liquid, then the upward force, that is the buoyant force acting on the body, is equal to the weight of the liquid displaced by it. Alright, now the weight that is displaced is of the ice because the amount of ice that has melted. So mass of ice that is melted will be equal to density of ice into the volume. Alright, now this volume and this volume are same by the Archimedes principle. Fine, if say this is the ice cube with a volume V and it is submerged with an upper layer just touching the upper surface of the liquid, so the amount of the liquid displaced will be also V because it is completely submerged. So the volume of the liquid displaced is also V. So I put V over here, so I get the mass of ice. Now again, no heat losses, so heat loss is equal to heat gained. Heat is lost by the iron cube, so heat loss will be given by mass of iron into specific heat of iron into T, that is the temperature of the cube initially. Final temperature of the cube will be 0 because it is completely submerged in ice now. And the second one is equal to heat gained, that is the mass of ice into latent heat of ice, because the heat is gained by the ice and because ice is melting but the temperature is not rising, so it will be equal to only ml. So I do have m of Fe as rho Fe into V into specific heat of iron as 470 into T is equal to mass of ice is rho of ice into volume into latent heat of ice, that is given to me as 3.36 into 10 to the power 5. So V is cancelled from both the side. I substitute the value of density of iron, that is 8000 into 470 into T is equal to density of ice, that is 900 into 3.36 into 10 to the power 5. So solving this equation for temperature T, I get the value of T as 80 degrees Celsius. That is the answer.